All right, welcome to day 2. Our homework is pages 19 to 21. So notice that's 3 pages of homework spread out so you'll be able to do your constructions. We will need compass and straight edge out. If you don't have either of those things, you can get one off of the front table and make sure to put it back at the end of the period. Do not take it with you after the period. We will need them for the other classes. So again, have your compass and straight edge out ready to go. And then you have a warm-up that you can be working on. For the warm-up, I suggest drawing a picture. And also, if you're stuck on question 2, look at packet page 5 to help you out. So we're going to pause the video for 5 minutes for you to be able to do these 2 problems. And at the same time, also have your compass and straight edge ready to go. All right, in our first triangle, we have AB is 5. DE is 15. BC is 8. We need to know EF. Well, I like to start with X usually. X matches with the 8. Then take something else from X's triangle, 15. That matches with the 5. When you cross multiply, you get 5x equals 120. Divide by 5, and you get the X is 24. Double check for units. We did not have units. We've got the triangles are similar again, so that means we know that sides are proportional and the corresponding angles would be congruent. AB is 100, DE is 120. The area of this one is 1,980 units squared. And we want the area of triangle ABC. So first off, our similarity ratio, if we do 100 divided by 120, that will give us 5/6. Before we work with our area, we need to make sure we have an area ratio. The area ratio is the similarity ratio squared. So we're going to have 5 squared over 6 squared. The 6 is coming from the 120, which its area was the 1980, and we don't know the area of the other one. So you should not be setting up a proportion involving an area unless you've done the area ratio on the other side, which means the side ratio should be squared. When we cross multiply that, we get 49500 equals 36y. Divide both sides by 36, and we get that y is 1,375 units squared. Moving over to homework. Letter A, cross multiply, divide to get B by itself. Either 33 halves or 16.5, both would be correct. In B, the 10 needs to be distributed through the x minus 3 to both terms. Get all the x's on one side, divide over, we end up with x is 6. Next one, we got to be careful about the 12 distributing through to both terms. You get 24b minus 12. Collect all the b's on one side, divide over, we get positive 12/9. That does not work out as a nice decimal, so you need to leave that as a fraction. And D, when we multiply those binomials, we'll have to distribute. So x times x is x squared, x times 2 is 2x, negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. If we combine our like terms, we then need to get everything on one side so it's equal to 0, so subtract the 7 over. And then we want to think about our multiplies and adds to. Multiplies to negative 15, adds to negative 2. If you're unsure of that, do in the calculator -15 divided by x in a graphs page and do Control T to look at the factors. But that should be a -5 and a 3. Set those each equal to 0 and solve, and you get x equals 5 and x equals -3. Our perimeter ratio is the same as our side or similarity ratio. So the first to the second would be 8/6, which reduces to 4/3. To get the area ratio, just square each of those. 4 squared is 16, 3 squared is 9, so we get 16/9. 14/21 reduces to 2/3 for our perimeter ratio. Square each of those to get the area ratio, we get 4/9. Question 3 was similar to the second warm-up question. Take your side ratio, reduce it, we get 2/3. Square each of them, and now that means we're setting up the area ratio. The 121 had to go in the bottom across from the 3 because that they told us was the larger area. Cross multiply and solve, and they wanted us to round to the nearest whole. We had 53.7, so that rounds up to 54 meters squared. Our side ratio here was 13/5, didn't reduce it all, so square it to get the area ratio. The 65 had to go across from the 5, because that was the smaller one. When we square them and cross multiply, we eventually get 439 meters squared. Now, they didn't tell us here for our initial ratio which one to which one, so it doesn't matter. Just when you set up your proportion, make sure the area is across from either the large or the small, wherever that may be in your fraction. Here they gave us our area ratios. So 4/16 reduce it to 1/4. The area ratio is the side or similarity ratio squared. So to undo the square, do the square root. Square root of 1/4 is a half, so your similarity and perimeter ratios are both a half. Ratio for B, reduce it to 25/4. If it's an area ratio, that means it had gotten squared, so to undo it, do the square root. We get 5/2 for both the similarity ratio and the perimeter ratio. All right, we're going to be working with compass and straight edge today. And first thing we're going to work with is creating scale drawings. The first one on page 11 we're going to do with a scale factor of 2. So what that means is we're going to make this figure be twice the size that it currently is. So the first thing we always want to do is we're going to keep one of the angles exactly the same. And when you're doing it, if it doesn't specify, you can pick any one that you want. So I'm just going to pick angle A to be the same. So what we're going to do is with our straight edge, let's just create a line. And this endpoint is where A prime is going to be. So what we're going to do is we're going to copy angle A. So with our compass, we want to put our point on A in the original figure, and we're going to make an arc of any size so that it hits both sides of angle A. So I'm going to make an arc. Notice it hits both sides of that angle. Keeping our compass the same, we're going to move this down to where A prime is. We'll put our point on A prime, and we need to make an arc. It's got to intersect our line segment we drew and be generous. Make it a pretty big arc because we don't know yet where it's going to intersect. So then we're going to take our compass and go back to the original picture. And we're going to set our compass so that our point is on one intersection and our pencil is on the other intersection. Then take your point, put it down on our intersection down here, and make an arc. And we're trying to get that new arc to cross our original arc. Wherever it crosses, you're going to take your straight edge and connect from the endpoint, and it's got to go through that intersection. So from the A prime, extend it through the intersection. So we've done the hard work here. Now we've just got to make sure it's a scale factor of 2. So what we do is let's measure from A to B with our compass. And we're going to put our point down on A prime and put a little mark. That's one set. Then we'll move our point to that mark and we'll make another arc. So now we have 2 sets. That tells us where B double prime will be. And the reason that's where B double prime will, or B single prime would be is because it's twice as long as AB was. And then we're going to do the same thing to find C. So in our original picture, let's put our point on A and our pencil on C. And then we're going to move down, put your point on A prime, mark off once, put your point on the arc, mark off another arc, where this intersected, that's C prime, and just take your straight edge and connect from C prime to B prime, and this creates a figure with a scale factor of 2. So our original figure gets multiplied by 2. Our new image now is twice all the lengths. So if we go to the next page, page 12, we're given an original triangle. We want to do a scale factor of 1/2. So that means all the sides should be half of what they currently are. So first thing we're going to do is we're going to copy one of the angles. I'm going to copy angle A again. So just draw some segment. We'll label this A prime. And we've got to copy our angle, so we're going to do the same process we did before. So we'll put our point on A and make an arc that hits both sides of the angle. Move your compass down, put your point on A prime, and make an arc. It's got to intersect our line and be pretty generous because we don't know where it's going to cross. So now we'll go up and measure our intersection in our original picture. So put your point on one of the intersections, pencil on the other. Then we'll move to our new picture, put your point on the intersection, make an arc, and we're hoping for them to cross. Wherever they cross, connect from A prime through your intersection, and that copies our angle. So we're guaranteed our angle is exactly the same now. So now what we need to figure out is how far to mark off on those segments. They need to be half the distance from what it was before. To get half the distance, we're going to do our perpendicular bisector construction. So let's put our point on A, and we're going to find what half of AS is. We'll want to open it more than halfway. We'll swoop it in both directions. Then we'll reverse it. We'll put our point on S. Swoop it in both directions. And then with your straight edge, connect those intersections. And we're concerned with where that line you just drew in, where it crosses AS. So what we're going to do is we're going to measure from A to that point we just found on AS. So set your compass to that length. We now know that length is half the length of AS. So we're just going to carry that down to our other picture, keeping our compass at that amount. And we'll just make a little arc. And wherever that cross is, that's S prime. So we've just got to do the same thing to find E prime. So we're going to do the perpendicular bisector of AE. So put your point on one endpoint. So I'm going to put my point on A. Make sure you're open more than halfway. And we're going to swoop down and swoop up. And we'll reverse it. Put your point on E now. Keeping the compass the same. Swoop it up, swoop it down. With your straight edge, connect those two intersection points. We're concerned with where that line we just drew in crosses AE. So we're going to measure the distance from A to that midpoint that we just found. So set your compass from A to that midpoint. We'll come down, we'll mark that distance from A prime. Wherever that hits, that's going to be E prime. And finish off by connecting S prime and E prime with your straight edge. And we've created a triangle that all the sides are 1/2 the length of the original triangle. So those are the hardest ones when you create a scale image where we have to copy the angle. If we go over to page 13, we're going to do a scale factor of 3. But notice this time they give us the angle already copied, G prime. So this is going to be much quicker. All we need to do to start out is with our straight edge, On that dotted line, extend it out a ways in each direction. And then we're going to take our compass and let's measure it from G to one of our other vertices. I'm going to go G to F to start out. After you've got it measured from G to F, we're going to start at G prime, and because it's a scale factor of 3, we've got to do 3 markings. And that third marking is where F prime would be. So point on G prime, there's arc 1. Put my point on the arc, make another arc, there's arc 2. Put my point on the arc, make another arc, there's arc 3. So this third arc, that's going to be F prime. So we'll do the same thing to find our third point, E. So put your point on G, open your compass up, so pencils on E. And we're going to do 3 markings. So point on G prime, mark once, mark twice. Now I can already tell I did not extend my line far enough. So if you found that that's the case for you too, you can extend with your straight edge. And then I'll go ahead and do my third marking. And where that third one is, that's our E prime. And then just connect with your straight edge from E prime to F prime. And this will have created a scaled figure with a scale factor of 4. Oops, my F prime is there. Going over to page 14, they give us ABC, the original, and they give us A prime, C prime. And they want us to first figure out our scale factor and then use it to complete the rest of the figure. So what we're going to do is we're going to put our compass on, or point on A, pencil on C for our compass. And we're going to see how many of these fit. So there's 1, there's 2. So it looks like our scale factor is 2. So what we have to do next to complete the drawing is we got to copy our angle. So I'm going to copy angle A. So put your point on A, make an arc that hits both sides of the angle. Then we'll bring our compass the same, put point on A prime, make a generous arc, meaning it hits once, but plenty of arc because we don't know where it's going to cross. We'll put our point on both intersections in our original figure. And then bring your point over to our intersection here. Make an arc so we get them to cross. And extend from A prime through our intersection a ways. Let's go to our original figure. We'll measure from A to B. And then we'll just have to mark off 2 of those. Because the scale factor was 2. So I'll bring my point over to A prime, mark it off once, mark it off twice. We'll call this spot B prime. We'll connect C prime and B prime. And there's our scale drawing with a scale factor of 2, which we were able to figure out by measuring the original length of AC and comparing it to the length of A prime, C prime. So what we're really doing here when we multiply by a scale factor is we're dilating our figure. A dilation, remember, is not a basic rigid motion because side links are not preserved. So if we go over to 15, when we dilate a point from some center, it multiplies the distance by some scale factor. So let's say O is our center and P is our original point. Let's say we called this distance x. Well, if our scale factor is r, this distance from O to P prime is just x times whatever r is. So think of it as if x was 2 inches and r was 3, O to P prime would now be 6 inches. When we dilate, it keeps the angle measures the same, but it changes the side length, so it's not a basic rigid motion. To do a dilation, we just need to know the center and the scale factor. So if we flip over to page 16, we are going to dilate this figure centered at O with a scale factor of 3. And these pictures, I think, end up looking pretty cool. So the first thing we're going to do is just with our straight edge, start at O and extend a line that goes through each of our points. So I'm going to extend a line through K. I'll start at O, extend a line through E, and start at O and extend a line through I. And extend them a ways because we're going to have to do 3 times the distance for each of them. So with our compass, we will measure the distance from O to K. Now, the key thing is that counts as the first one. There's going to be 3 total. That's the first. Now put your point on K, make a mark. That's the second. Put your point on a mark, make another mark. That's the third. So scale factor of 3 just means there's 3 total parts. So this would be K prime. We'll do the same thing for the other ones. I'm going to do OE next. I'll put my point on O, pencil on E, and that length will count as the first one. So that's 1. Move your point down to E and make a mark. That's 2. Put your point on the arc, make another arc. That's 3. So that would be E prime. And then same idea for the last one. Point on O, pencil on I. That's your first. Point on I, make an arc. That's your second. That's your third. So that's I prime. Oh, I forgot to, I guess I labeled it E prime down here. But what we're going to do is connect our primes now. And that creates our dilated figure with a scale factor of 3. And the reason dilations, we're doing this in this unit, is when you dilate it, it creates a similar figure. The angles that are in the same spots are still the same. The sides, they're in some proportion. And the proportion is the same as the scale factor. We're going to skip page 17. Page 17 is the same thing, just you'd be doing it with a scale factor of 2 instead of a scale factor of 3. If you didn't have your points letters on each of your points, say you just had some figure like that, you would just pick your points to be the key spots. So you would just dilate those key spots and then just reconnect them. But we're going to finish off with question 7 on page 18. So here they give us our original figure and the image, and we need to find the center. So all we're going to do is with our straight edge, connect from A prime to A and extend it a ways. Connect from B prime to B and extend it a ways. And connect from C prime to C and extend it a ways. And you should find that they all cross in one spot. Well, the directions say that's our center, and to label it O, so we've just found our center of dilation. So A prime, B prime, C prime was found by taking the distance from O to A and multiplying it by some scale factor. Doesn't look like it's quite 2. It's probably something in between 1 and 2 that the scale factor was in this case, but we didn't have to figure out what it was. We just had to find the center. So you've got the day 2 homework. Any time left in the period you can use to start doing that. Have a great rest of your day.